Here the big question is that for a decision tree, actually we need the feature standardizations that we will see in logistic regressions. If you just remember logistic regression and support vector machines, also k nearest neighbor. Just if you remember, in such scenario, we will do when we are processing our data. This is the primary thing for standardizations. So here this is sure and primary processing technique here for this kind of techniques. Feature standardizations means what? Suppose let's take we have a data set like that. Suppose let's take we have a data set like that and like that, and here we have the data. Suppose like here we have one features. Suppose like here we have the feature. Suppose it's called fj features and corresponding value for these features. Let's take this is the features j and corresponding its data value is, suppose let's take xi, its data value xi. So what will be the value? Suppose let's take for this data xi and for corresponding the features fj, its data value is xij. Okay, let's take its data value is xij. Then how we will doing that stitch feature standardizations technique? How we will perform this technique? So the feature standardization technique will perform like that. Xij dash is equals to xij minus mu j divided by sigma j. So what is the mu and sigma j? So mu j is simple the mean of these features, all the mean of the values for these features. Okay, mean for the values of for fj. So mean of fj is for the mu j, and standard deviation of fj is called the sigma j. We have already seen. So using this technique, we have standardized our features. So here is for this data set of data set, we have seen that here data sets mean is equals to, for this data set is equals to 0 and standard deviation is equals to 1 by simple doing this job. We have already seen this thing, but here actually we need this thing. So if you just recall logistic regressions, SVM, KNN, they are what we are actually doing. In logistic regressions and SVM, we are doing find the distance of a data point. Suppose let's take we have a data point here. Then we will find the distance from a plane. We will find this distance from the plane pi that we will see in the logistic regressions and SVM. That's technique we have already seen. And KNN, what we are doing KNN, in KNN we have a query point xq, and near we will find it according to the distance of the near point. We will find the distances from the near point, from is near point, and according to the distance we will choose the k nearest point that we will see in KNN. Actually we have to find the distance for logistic HBM or KNN or as well linear. So we will have to find the distance. But here, just if you just remember the previous lectures, here we have not find any distance. Here we are just using the, here we are simple using the if else conditions to find the conditions, to find the, suppose to find the criteria. We will simply here use the if else condition, nested if else. If else means nested if else conditions. Here we will just nested if else condition. Here we are using nested if else. Here we actually we don't need any distance based method. So here actually what we have the main thing that actually we have to do here. So the main thing is that here, suppose if we have a data set and corresponding, suppose let's take it's the features. Suppose let's take it's the features J corresponding to this data set. Suppose let's take it's the features J corresponding to this data set. Then what we actually doing? So if we have, suppose let's take if we have a numerical features. Suppose like this is a numerical quantity. These are the numerical quantity. Suppose let's take it's a numerical feature. And it's the numerical. Then what we are doing that first we are sorting these features. First what we have to do, what we have to do, we have to sort these features as ascending or descending as you like. Okay, so according to the sorted features we will decide the threshold value. Suppose let's take here it is our threshold value. Suppose let's take this value is our threshold value we have chosen here. This is our threshold value. We have to choose the threshold. I think spelling is okay. Threshold, THRE is usually okay. If I have done some mistake, please correct it. Okay. So this is, suppose let's take this is tau is the threshold value. Now according to this tau, suppose let's take after some depth of the decision tree, according to these features, for these features according to this threshold we will splitting our tree. If this threshold value is yes, then we are going this value. If this threshold value is greater than less than this, then we have reaching this portion. If this is no, then we have reaching this portion. So just such kind of splitting we have already seen. So first actually we are doing the sorting technique here. First we have doing the sorting for this column for these features. Then according to the order, then we are finding the order. Yeah, just we need the order only. Yeah, just only we need the order. Don't need any distance. How much far it is and how what kind of data. Don't need to standardize in the same scale. Just we have to check the conditions. So just we need the main thing here. We need that order. Okay, that is the important thing. Only because of this here we don't need any here actually we don't need any feature standardization technique. Here actually we don't need feature standardizations for decision tree. Okay, because why? Because only for these reasons. Because you don't need to perform, because here we need here only we need the order. Here we don't need any distance measurement. Okay, here I don't need any distance measurement. Only we need that the order. This is the main reasons for decision tree. Because of these reasons, only because of these reasons, we don't need any feature standardizations in a same scale.